All right, so we've got two parts to our lesson today. So the first part is about sequences of transformations. So remember, we've got two different types of transformations. We have our rigid motions, which you remember keep things the same size and same shape, or otherwise congruent. So those are our translations, rotations, and reflections. And then we have our non-rigid motions, which may stretch or compress something in either a vertical or a horizontal direction, or possibly both. Sequences of transformations, though, in general, are when we apply more than one transformation at a time. So we're going to be taking some of these and kind of doing multiple things to a figure instead of just one transformation at a time. So just so that you see an example of what this looks like, they're going to give us a figure. So in this example, they've given us the triangle ABC, and they've told us to do two things to it. First, they've told us to reflect it across the line L. So we're going to be flipping it across this line, and then we're going to translate it along the vector V. So notice the first thing that they've done down here is reflect it. So remember, when we reflect, we do that perpendicularly. So we'll keep working on that skill. And then we're going to translate that along this vector V, which would mean to move it up 1 unit and to the right 4 units, which is then what they've done. Notice also with the notation, if I zoom in here, notice with the notation that the pre-image here has no primes with it. It's just the original A, B, and C. Our reflection is A prime, B prime, and C prime, and then our final image, which is after that translation, becomes A double prime, B double prime, and C double prime. So just kind of be aware of that notation, that this is 1, 2, and 3. All right, so let's take a look at one of these examples together for your notes. So if you see here, they've given us a series of transformations. So we're just going to do one at a time. So this first transformation, you could either list out the coordinates, or you could just do what it's telling you to do. And if you recognize and remember, addition and subtraction are translations. So x minus 1 is going to tell me to go to the left 1 and down 1 in the y direction. So I'm going to move each of my points to those new spots, left 1 and down 1. So that's A prime, C prime, and B prime. Notice that that is staying congruent to what it was before. All right, my next problem says that I need to stretch this, let's see, x direction, so stretch horizontally by a factor of 3. And the easiest way, I think, to do that is to actually write out the coordinates to perform that operation. You are doing that using the previous image, not the original image. All right, so I went ahead and listed out the coordinates that we had so far. I'm trying to kind of color match here. So if I stretch horizontally, that means I'm going to get 3, 1, 3, 4, and 6, 1 for my next set of coordinates. So if I go ahead and plot those, I'm going to get an image that looks like this blue triangle. So notice on that blue triangle, vertically, this did not change. So the height is still the same. It's just that in the horizontal direction, this is a wider triangle than it was before. So notice, like, from A prime to C prime was just 1 unit, whereas A double prime to C double prime is 3 units wide. All right, our last translation that they're going to ask us to do is this negative x, negative y, which you may recognize from your notes if you are remembering those tables as a rotation. However, you know, I don't do well with memorizing that. So for me, I'm just going to write the coordinates out. So that's going to become negative 3, negative 1, negative 3, negative 4, and then negative 6, negative 1. And if I go ahead and plot those points, my final image is going to look like this green triangle down here at the bottom. Notice that on every stage, it's very important that I label my points so that we see what's corresponding. So make sure that you're doing that same thing for your notes tomorrow. All right, and the only other thing I want to add, just kind of for good practice because of what we're going to do with it, it is probably good, even if you do this all in coordinates, it is probably good for you to go back and say what transformations are happening. So obviously this first is just the pre-image. But then we can make a note that the first thing we did was we translated, and we should probably say that we translated left 1, down 1. And then in blue, let's see, that was a, what did we say, vertical stretch. And we can say by 3. And then the last thing we said, we figured out, even if you don't know it when you first look at the coordinate notation, when you actually perform the transformation, you should see that that's a rotation by 180 degrees. So let's go ahead and get in the habit of naming all those transformations either before you do them or after you do them, just so that you're recognizing everything that's occurring in the problem. All right, so now we're to the last part of our notes, which is section 3.2, proving figures are congruent using rigid motions. So we know that rigid motions and congruence, those two things go hand in hand. We're really just using and defining which rigid motions occur so that we know things are congruent. So like they're telling us, I'll show you a problem here. They're telling us that these two figures are congruent, and the question would be why? Well, this is an example of a translation. So because this is a translation, they are congruent. All right, the next example here, think about what rigid motion would be causing these to be congruent. And hopefully you're seeing that this is a reflection, right? This could be reflected across a line I could draw here between those. And then our last example, this one, these are not congruent, right? They're different sizes, which is why they're not congruent. So this is not a rigid motion, which is something that we would say at a problem like this. So let's look at like an actual example. Okay, so in this example, they're doing a few things. Notice that they're telling us that a figure is congruent, and they're telling us which coordinates match with which. So this statement tells us that A and J correspond to one another. So we're trying to figure out getting this point A down here to point J. So the first thing we want to do is just list what are the transformations in words. Okay, so I color-coded 2 more points for us. So if I see this, now I will tell you, sometimes it does not matter the order, and sometimes there are multiple ways to get there. So I see that in general, this is probably going to be some sort of a reflection, because I've got to change the orientation. And then obviously this is going to have to be moved down in some sort of translation. So let's go ahead and write those 2 things out and then maybe figure out exactly what is happening. All right, so I'm thinking let's start with the reflection and then we can move to the translation. Now you don't have to do that, it's in that order. And you may actually find another step that you could do or some other ways you could construct this, but this is just what I'm seeing right away. So if I reflect this, I know I'm going to have to reflect, and I'll be more specific, across the y-axis. So we need to think about where that will land us. So if I do that, I'm going to map kind of my new points out here, and I'm not being very specific, even though I should be. All right, so here's my new figure. So that's a reflection across the y-axis. So if I do my coordinate notation for my reflection, that is going to take all of my, so my y coordinates will stay the same because it's not moving up or down, but my x coordinates are changing sign, right? They're going from the positive x's to the negative, so that's negative xy. All right, and then I want to translate this down. So my translation, now it's not just down. It's kind of hard, it may be a little bit difficult for you to see, but think about these points that are matching up, right? This is my A prime, and I'm trying to get it down to where J is. So that point, and all of the others for that matter, are going to end up moving, let's see, to the left 2, because notice that this graph is counting by 2s. So to the left 2, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, that's to the left 2 and down 10. And we know when we write that notation, that's going to give us to the left 2, so that's x minus 2, and down 10, which is going to be y minus 10. So mostly we just need to spend some time practicing how to make this happen for class tomorrow.